Can a child be born before its mother? Such a beginning may be good for a joke or a science fiction film. After all, everybody knows that there's no egg without a chicken. And a child can't be born without a mother. But maybe different laws apply in outer space. Astrophysicists at Johns Hopkins University believe that most matter in the universe existed before the Big Bang. But is this possible? And what kind of mysterious and ancient matter do scientists have in mind? 100 years ago, no one knew that in space there's an invisible component. However, over time, science has generated more and more questions. For example, why do stars in many spiral galaxies move so fast? Furthermore, the gravitational field created by stars themselves is not enough to keep them in orbit around the center of a galaxy. And that means there must be something else there. Scientists have called this invisible substance dark matter. They've calculated that our universe is 22% dark matter, 74% dark energy, and only 4% ordinary visible matter. Stars are ordinary matter, which, according to some estimates, there are more than 206 trillion of them in the universe. That's 200 times 10 to the 21st power. And there are innumerable planets, black holes and other space objects. And all this pulls in only 4% of matter. Can you imagine how much dark matter is in the world? If its mass is so much more than normal matter. But scientists still know little about the composition and physical properties of this dark horse, which makes up the bulk of the universe. It's difficult to study what is impossible to see. Indeed, unlike ordinary matter, dark matter doesn't reflect or absorb light at all. However, recently it's become possible to partially illuminate this invisible component of the universe using the Hubble Orbiting Telescope. Astronomers have shown how dark matter surrounds the collision area of two massive clusters of galaxies, with an expanding ring called SL0024+17. Additionally, researchers traced its influence on the formation of early quasars, galaxies and gas clouds. This confirmed the hypothesis that in the early universe, dark matter was not evenly distributed but scattered out into lumps, taking part in the formation of various space objects. In turn, scientists from the Institute of Astronomy at the University of Cambridge claim that they're able to determine some of the physical properties of this invisible matter. Astronomers have observed 12 dwarf galaxies around the Milky Way. The results showed that these galaxies contain 400 times more dark matter than ordinary matter. The speed of particles there reaches 9 kilometers or 5.59 miles per second, and the temperature is 10,000 degrees Celsius. That's 18,032 Fahrenheit. The work of these researchers from Cambridge became another argument in favor of the theory of hot, dark matter. However, in the generally accepted cosmological model, the most probable case is the existence of cold, dark matter, which doesn't move so fast. Different ideas are being expressed about the particles of dark matter. But in any case, they must be different from ordinary particles. They don't have an electric charge or perhaps have a very weak charge. So this particle is not like electrons or protons. It must interact very weakly. Therefore, it can't consist of neutral elementary particles like neutrons. In addition, it should have a relatively large mass. So neutrinos are not suitable for this role. Most likely, this is a new type of particle that we just haven't seen before. According to another hypothesis, dark matter may exist not in the form of particles, but in the form of huge black holes. Scientists remembered this idea in connection with the discovery of gravitational waves that arise when cosmic bodies merge. But so far, it's not clear where so many black holes could have come from. Also, there are many astrophysical restrictions on the density of black holes. Finally, There's the theory that dark matter can exist in the form of a wave passing through the universe. The velocity of this wave determines the amount of dark matter. But most scientists still lean toward the fact that dark matter doesn't exist in the form of massive black holes and waves, but consist of particles. A new solution to the riddle is offered by experts from Johns Hopkins University. Astrophysicist Tommy Ten-Kernan suggested that dark matter might have arisen before the Big Bang. The period of cosmic inflation when space very quickly expanded. Ten-Kernan reinforces the hypothesis, which is in fact by no means new. With mathematical calculations and in this case an extremely accurate science, mathematics is trying to turn the story upside down, forcing the egg to appear before the chicken. So far, experimenters have not been able to detect particles that would indicate that dark matter is the remnant of the Big Bang. According to CNN searches cannot succeed in any way precisely because dark matter appeared earlier during the inflation of space. A large number of particles of a certain type, the so-called scalar particles, arose. The author of the study is sure that if dark matter has something in common with any scalar particle, then it can be older than the Big Bang, which means that it arose even before the birth of the universe that we observe today. However, the problem is that so far the only experimental discovery of scalar particles is the Higgs boson. And to study it is extremely difficult. So far, assumptions about the early emergence of dark matter remain only a hypothesis. But Tommy Ten-Kernan is encouraging with his key conclusion. Dark matter should have left a unique imprint on the large-scale structure of the universe that formed after the Big Bang. That is on the distribution of galaxies and their clusters. This means that the hypothesis can be verified by astronomical observations in the near future. Scientists expect to receive evidence for this during the space mission Euclid, the launch of which is scheduled for 2022. Or experiments using colliders could clarify the situation. It's assumed that dark matter particles are 100 to 1000 times heavier than protons. In this case, they could be obtained in collisions of ordinary particles boosted to high energies in colliders. Also, you might find particles of dark matter right at your fingertips while you watch this video. You are surrounded by about 1,000 particles of dark matter per cubic meter. That's 28 particles per cubic foot, assuming that their mass is equal to 1,000 masses of a proton. Although such particles interact weakly with particles of ordinary matter, sometimes they still collide with each other. Physicists hope to detect this phenomenon. The search is conducted with the help of a number of highly sensitive detectors deep underground where cosmic radiation doesn't reach. Still, researchers hope to register products formed by the annihilation of particles of dark matter among themselves. That is the consequences of their mutual self-destruction. The result of which is other particles, for example, neutrinos, which neutrino telescopes can detect and which are supposedly formed sooner or later. One of the methods will likely work, and scientists will have the chance to learn all about the birth of dark matter and its properties. And at the same time be able to verify many theories connected with it, which for now sound rather fantastic in one such hypothesis. Lawrence Krauss and Glenn D. Starkman from Case Western Reserve University in Cleveland, Ohio, and Vanderbilt University even declared dark matter the culprit of a future apocalypse. As a result of the annihilation of its particles, the reserves of dark matter should gradually decrease and the gravity that binds galaxies together should weaken. Ordinary matter, according to the authors, will become extremely dispersed and it will be completely impossible to live in such a world. Fortunately, if this happens, it will be far in the unimaginably distant future, according to the estimates of Krauss and Starkman. The apocalypse is likely to come when the age of the universe is 10 to the 10th power times older than it is now. which at the moment is 13.7 billion years. So in any case, we have enough time to study dark matter and find out if it really is older than the Big Bang. So what do you think? Can we solve this mystery of the universe? If you like the video, give it a quick thumbs up. Subscribe to the channel and click on the bells. You don't miss any new releases. And don't forget to invite your friends. These topics are always much more fun to share together. Until next time.